In Lesson 7, we're going to be discussing transformations in the coordinate plane. And you know just from the word transformation that a transformation, when somebody undergoes a transformation or something undergoes a transformation, it's a change. And we're talking about figures graphed on the coordinate plane. So by definition, it says that a transformation is a change in the position, size, or shape of a figure. The original figure is called the pre-image. The resulting figure is called the image. A transformation maps the pre-image to the image. Okay, so the pre-image is like the before, and the image is like the after. They point out to us that arrow notation is used to describe the transformation, and that primes are used to label the image. Okay, so this is what they're referring to when they talk about arrow notation. And this statement reads that triangle ABC is mapped to triangle A prime, B prime, C prime. And these little tick marks here are what they're calling the primes. Okay, so we have our before, the pre-image, our after is the image. The transformations in 1.7 should all be familiar to you. The transformations that they review with us are the reflection, the rotation, and the translation. And when you talked about these, probably in middle school, you talked about a reflection as being a flip, and a rotation as being a turn, and a translation as being a slide. We are going to try and use what I would call our high school terminology, and so we're going to refer to them as the reflection, the rotation, and the translation. And again, you can see the image to the pre-image. They have them denoted, the images with the prime tick marks. All of these three transformations, you'll notice that all the figures remain the same size. They simply are changing their position. On the back side, when you take a look at problems like example A, they're going to ask us to identify some transformations and to also use arrow notation to describe it. So we look at number 1, and we're comparing our pre-image here to our image. Well, I can see that it is simply rotated. In order to map one to the other, I would have to take this and turn it. And so I'm going to identify it as a rotation. If I'm going to use my arrow notation to denote it, I'm just going to say that my triangle, XYZ, maps to triangle, X prime, Y prime, Z prime. In number 2, I am comparing my rectangle, MNOP to M prime, N prime, O prime, P prime. I can see here it was a slide, and so we're going to say that it was a translation. And my arrow notation, sometimes you see this little symbol used for rectangle. Other times they might just list the letters. There will be my arrow notation. Example B, it says that we have a figure with vertices at A, 1, -1, B, 2, 3, and C, 4, -2. After a transformation, the image of the figure has vertices A prime, -1, -1, B prime, -2, 3, and C prime, -4, -2. Draw the pre-image and the image, then identify the transformation. So it's important to know they're wanting us to do a couple things here, to draw both images and then to identify my transformation. If I go ahead and I plot my pre-image of A, B, and C, a reminder that we have our XY coordinates here. So 1, -1, meaning going to the right 1, down 1. 2, 3, meaning to the right 2 and up 3. And 4, negative 2, to the right 4, down 2. Plotting those points should be review for you. Now when I go to do my image, my resulting figure, I see A prime is negative 1, negative 1. B prime is negative 2, 3. And C prime is negative 4, negative 2. And just by comparing the numbers, you may have been able to determine what was going to happen. Once we draw the figures using the picture, it's pretty easy to see, well, one is simply reflected, right? So my identification of this is going to say that it's a reflection. I could even be more specific by saying it's a reflection over the y-axis. And this lesson is simply kind of an introduction to our transformations. We'll talk more about these in Chapter 4. Finally, you'll see in the middle of the page this starred note here that your translations can be described by a rule that looks in this form right here, where it says my point xy maps to x plus a comma y plus b. And we would be substituting numbers in for our a and our b. So when we take a look at example C, they have given me my triangle ABC, and they say we have a translation of xy mapping to x plus 2 and y plus 1. Now there's actually a couple ways that you could go about doing this question. They're wanting us to find the coordinates, and a lot of times they'll also ask me to sketch or to draw the image. As I can see here, my figure ABC, well, maybe if I wanted to go ahead and identify those coordinates, I can see that my point A is at negative 4, 2, my point B is at negative 3, 4, and my point C is at negative 1, 1. Now really, I could find my new coordinates algebraically just by substituting in. Using my rule, I can see my x coordinate is going to be added 2. So I'm going to take negative 4 plus 2. And my y coordinate is going to be subtracted by 1, which would give me the result of a prime being at negative 2, 1. So we're simply plugging it in for x and y. All of my x coordinates are increased by 2. All of my y coordinates are decreased by 1. And then I could go ahead and I could plot A prime, B prime, C prime. Now the other way to do that is to strictly use my picture first, and knowing that my x coordinates would increase by 2, I actually know that they would shift to the right 2, correct? And that my y coordinate will go down by 1. So if I take my point A and I go over 2 and down 1, this would tell me A prime. And I could do that with each point. And then I could just look at the graph to use my coordinates. So you could do it either way. You could use the graph and translate to find your coordinates, or you could substitute algebraically. Honestly, I would like you to be familiar with both. Okay, if you have further questions, please come and see me. Like I said, this is an introduction, and we'll talk more about